Welcome to the video lecture for section 7.4, entitled Variation. So in this section, we're going to be looking at functions from a slightly different perspective. Variation is the mathematical concept of expressing relationships between quantities, and we usually call those quantities x and y. Now, this is a familiar idea. We've done this with functions in the past. However, a lot of our equations that we set up are going to look a little bit different. We'll see a bunch of different kinds of variation in this section, as well as what to do with those types of variations in different situations. So the first type that we're going to look at is called direct variation. I'll refer you to the definition of direct variation, definition 7.6, right at the beginning of the lecture notes for section 7.4. So, in any situation involving direct variation, which we can tell is what's going on here, if we read through the words, the charge for staying at a hotel varies directly with the number of nights stayed. So directly there is our key word. We are talking about direct variation between these two quantities, the number of nights stayed and the charge for staying at the hotel. So the definition for variation is that we say that y varies directly with x, or sometimes y is directly proportional to x, if y equals k times x. In other words, if there is some way of, some constant you multiply x by to arrive at y, which in this case we can see is what's going on. So the next step is usually assigning a variable to the quantities in question. So we say the charge for staying at the hotel varies directly with the number of nights stayed. And just to refresh, we say that y varies directly with x when this is happening. So that tells us that we want y to stand for the charge for staying at the hotel, and we want x to be the number of nights stayed. Now this is not a coincidence. Previously we've seen x representing the independent variable and y representing the dependent variable, and that's exactly the same situation here. We have the number of nights stayed affecting the charge for the hotel stay. Now, additionally, we're told to assume that at this 4-star hotel in Orlando, there's a nightly rate of $302 for a suite. In other words, staying for one night, if x equals 1, y, the charge, is going to be 302. Now, putting these three concepts together, we see that 302 is equal to k times 1. And that means that k is 302. So our model, if we want to put this idea together with the structure of our equation, we would say our model is going to look like y equals 302x. Now this is probably something that we could have figured out using other approaches. Way back in chapter 1 we saw a lot of setups like this. But this one is a good example to kind of introduce the idea of variation using something somewhat familiar. Alright, now part B says, or asks us, what is the charge for a 7-night stay? Well, that means that we're letting x be 7. So if we let x be 7, what happens with y, the charge? So using our model, 302 times 7, the number of nights that we're staying there, if we crunch those numbers, we get 2114. Okay. In other words, the charge is $2,114. So now that we have this model, we should be able to graph it relatively easily. In fact, all of the models that we'll see in this section can be graphed using techniques that we've already learned. So if you set up your axes, the first thing that you want to do is label them, and since we've assigned x to represent the number of nights stayed, we can say our horizontal axis will represent nights, and our vertical axis will represent the charge. Okay. Now going back to the model that we found in part A, we have y equals 302x. Now that is something we've seen for a long time. That is a linear model with a slope of 302 and a y-intercept of 0. So we can start our line at 0, 0, and our slope is positive, so this should be an increasing line. Now it's not a bad idea to label a few points on this line, so the first point, we could say after one night your charge should be 302. After 2 nights your charge should be double that, 604. After 3 nights your charge would be 3 times 302, or 906, and so on. So just to label a few of those, we've got 1 point right there, our second point that we calculated right there, and our third point just a little further along. Now, variation has this new idea that we call the constant of variation. And again, going back to the definition in the notes, the constant of variation is the name that we give to this quantity k. So in this case, we already determined that k was equal to 302, so the constant of variation is already known. Now, the constant of variation is what gives each variation equation its uniqueness. In this case, our slope, our variation, was 302. Now, at a different hotel with a different nightly rate, that would be a different number. So that is ultimately our goal. First, we'll figure out what type of variation we're talking about. We'll refer to the notes as necessary to see what that formula, what the shape of the equation or model should be. Then we assign variables to the quantities in question. In all of these cases, we're going to have parameters. In this case, we were told that one night in a 4-star hotel cost $302. That narrowed down our situation so that we could set up our equation and get to the exact model for this scenario. Once we have that, we might be able to then use our model to make predictions about slightly different situations where you hold everything else constant but change maybe one parameter. In addition, we usually want to figure out what is our constant of variation. So that is going to be our strategy going forward with all of the problems that we'll see in this section.